think we can get this show on the road. Let's stop that song there. I don't know why, but I usually play that song. I don't know if Andrew's here. He might be off, getting some stuff done. But we'll go ahead and get this started. Hopefully everybody out there is doing all right. What the fuck is going on here? I don't know what that is. That little tune that I had playing there, StreamYard has it listed as Feed the Ducks. That's what it's called, Feeding the Ducks. So that's why I picked that tune, because the name just, I don't know, I like it. I will be posting the link shortly. This is going to be an open mic. Again, I'm limited to 6 because I'm not giving StreamYard money. I don't need to. But we're going to be at least initially talking about the debate that me and Grayson had on Modern Day Debate on Tuesday night with Rebekah and Sal on the merits of the Big Bang model. I've sent the link to Andrew, who is here, and Grayson. I don't know if Grayson will be joining us at any point. Hopefully he does. But again, I will be throwing the link out probably in 10, 15 minutes. I'm going to share some of my thoughts on the discussion, have Andrew share some of his thoughts on the discussion, and then probably let people in to talk about either the debate or any other topics that have been on other people's minds. I don't want anybody out there to think that if you come in, you have to talk about the debate. Obviously, these open mics go in many directions. So Andrew has not unmuted yet, so I'm assuming he's probably still AFK at the moment. So I'll just jump right in with my thoughts on the discussion. I'm sure Andrew will let me know when he's back. So I thought that, and if you haven't seen the debate, you should. I know a lot of people don't like to watch Modern Day Debates channel for some reasons. That's fine. I will be mirroring it to my channel probably either next week or the week after. I do like to give it some time in between, just so, the kind of, it dies down a little bit so that people, when they see the debate reposted, there's still some sort of interest there rather than posting it immediately after everybody just watched it 2 days ago on another channel. So I will be mirroring it to my channel for those that want to see it but don't want to watch Modern Day Debate. But it was a phenomenal discussion. I really did like how Rebekah and Sal approached the discussion from a scientific perspective. This wasn't a discussion that was focused on the religion. I actually really did like that, because I think that oftentimes when the religion is a part of it, we can get really bogged down in that, and then we're not focused on the more scientific aspects I think personally are more important to actually gaining a meaningful understanding of these subjects. So I really did like that. I thought that I actually really liked the layout for the debate. Rebekah and Sal kind of was effectively 3 separate openings, but that was fine. I think that me and Grayson handled it very well. I think that we provided very meaningful and informative responses to all of the points that they brought up. But I actually did like the format, because it gave Rebekah and Sal a chance to offer up different evidence, but I just think that me and Grayson were successful in tearing that down and explaining why it doesn't align with the empirical data that we currently have on hand with respect to cosmology. I was very, very impressed with Grayson's performance. I knew that I was going to be. He's not a stupid person at all. But I was very impressed with his performance. Oh, I see he's in the chat. Well, here, let me go to you. I'll just throw the link in now then. Paste. There we go. Yeah. But yes, I was very, very pleased with his performance. I would definitely do a team debate with him again, particularly which Grayson's pretty good with some science stuff. I've watched a few videos on his channel. He's pretty good, and I've watched a few of his debates. He's pretty good with the science stuff. So and that's one of the reasons why I like his channel and why I recommended this debate, because I wanted Grayson's name to get out there. I want people to go subscribe to his channel, and hopefully he's picked up a few subscribers since the debate. But I really did think that it was a good discussion. I think Sal and Rebekah, with respect to the position that they were defending, look, I'm going to give credit where credit's due. I think they did a pretty damn good job of defending their position. I just think that our position was much stronger, and that me and Grayson were capable of showing that it is a much, much stronger position to have. So with respect to, well, actually, I think Andrew is here now, so I'm going to shut up, and if he is here, I'm going to let him give any thoughts he has.
Yeah, thanks for having me on. Yeah, I mostly agree with the format was pretty good. I wish there was a little more open discussion just so you guys could discuss it a little more back and forth. But yeah, otherwise I agree with you that um, the more science-based approach was I think I could tell it was going over some people's heads in the chat because they were kind of either just throwing around insults or just talking about unrelated things. But otherwise, yeah, I think the science-based approach was definitely better than the religious one, even though it may have been less entertaining to some people.
I will say we seem to average about 390, 400 for most of the debate. So I was gonna the viewership that you get on debates on MDD can really be hit or miss. You're usually going to have more than about 200, 250 at minimum. But like if you go watch the debate that Matt Dillahunty had with Posh like 4 or 5 days ago, that's already at like almost 50K views, but it's got Matt Dillahunty in it. So
Right.
but I was actually, I was like, I was pleased with the viewership, which I like to look at viewership, not because I'm conceited, but because I want to see the level of interest people have in these kinds of ideas. And I think that a good way to gauge that is how many people come to watch these kinds of debates, you know? But
I just want to make the point that at the maximum that I saw, our maximum viewership was at 420. So just had to point that out.
yeah, I think that's what I saw too. It was like either 420 or 430 or something, but I did see it at 420 something for a while there actually.
Yeah, it was a great debate, Leo. I thought we did. I thought we did a great job at least addressing as many points as we physically could within the time constraints.
Mm-hmm. And feel free to take this time to rant and rave about any thoughts that you had. And I'm willing to bring up either myself or if either of you wants to bring up and share any particular moments from the debate or anything like that. Feel free to do so.
Yeah, I had a few thoughts if you want me to go first. I may mute here and there because I don't know how my dogs are behaving right now, so they may abruptly start barking. By the way, is my audio going okay so far?
Oh yeah, coming in clear.
Yeah,
good volume.
I know sometimes I robot and I don't want that to happen, obviously. Let's see.
Well, I'm on my phone here, so the power unfortunately went out. That is the nature of the Texas power grid.
Oh,
is even just a light wind will knock it down for an unforeseeable amount of time. So I'm on my phone's battery right now, no Wi-Fi. So hopefully I'll be able to stay on for a bit.
Yeah, if you have to take off, just let us know. It's no worries, because
good to see you again, Grayson. I thought you guys did pretty good.
I did want to say one thing while you're pulling up which I'm assuming you're gonna pull something up from the debate, Andrew, which again is fine. Was that I think Grayson and I think we were able to respond to pretty much every point that they made. And I was actually glad that you had mentioned something about getting closing statements, because I was almost about to say something for the same reason that, like, they did bring up like a bunch of brand new points. So I do think it's fair that we get. So yeah, I was definitely happy about that.
Well, in the format that they did, what they essentially did was 3 different openings. Like they had 3 separate 10-minute PowerPoints that they had prepared. And no matter what we said, they basically just went into a new opening every time they were given 10 minutes.
Right. Yeah. Really stick to one particular topic.
That's why I think
that there's one topic that I don't know. I don't think that we really did address, and it kind of seemed like, I don't know, maybe you would disagree and you said that we addressed it, but there was like a paper that they kept bringing up, right, with the new JWST data and the plotting, and supposedly showing that it doesn't align with
it's funny you bring that up. I actually have a thing or two to say about that when you're
exactly. So that was my first time seeing that plot. So I actually, in the time since then, I've gone and I've looked at that paper, and I wish that I had known about that paper or had called out that paper and that line of their argument during the debate, which I don't think I did. Leo, you might have, but
Was that if it's the same one I'm thinking of, I might be misremembering which particular
it was
citation that Sal brought up, but I
Sal
do
illustrated
remember
it. Do you remember he did the basketball plot, and he had a little cartoon basketball, and he showed here's the prediction for how the basketball would change size as it
yes, the
distance and
angular
redshifted.
Yep.
Yes, so the angular diameter. So the angular diameter argument, I feel like I wish that I had more called that out as BS and shown why that was resting on unreasonable assumptions about saying like, oh, so you in order to make that plot, you have to assume implicit in your little lambda CDM, here's our expectation. You have to assume that it's the same size basketball that you're looking at the entire time. And that's the only way that you have that little curve of expected values that we don't see, because why would we make the assumption that the very earliest galaxies are the same as the galaxies are now, the same size, the same brightness? I mean, I don't see a good reason to make that assumption, but that's the assumption that's implicit in what was Sal's argument.
It also assumes, and I do think I briefly mentioned this, but no, I don't think that we really touched on this very deeply at all. We probably should have, but it is what it is. They threw so much shit at us.
Yeah.
They were just throwing the kitchen sink at the wall and seeing what sticked. But hey,
well,
I give them props for doing a better job than a lot of others have.
Yeah, well, I would agree.
To be fair, they did do a recent stream on it, like relatively recently, so they probably found or either the paper was I don't know if it was published per se. It was in a journal with subpar peer review.
Yeah, okay. I looked that up as well. It's in the Galaxies journal, which is already not. I mean, they say that. So there's some peer review that goes into it, but the specific article that they have literally comes with a disclaimer that says, "Hey, this has not been peer reviewed yet."
Right.
And if you look at the authors, it's a computer scientist,
no astronomer,
a mathematician, and then somebody whose address is literally a construction supply company.
Was this was that the paper? Oh my God, what the hell is his name? That relates
it was
to
only
the
published in
axis
December.
of evil?
No, it was only published in
never
December
mind.
it was only published in December of 2022 in this Galaxies journal, but you can only find it on online, not on the journal's website, and it says it hasn't been peer reviewed, and it's not by astrophysicists. So,
but I did want to say about the angular thing. I do remember pointing out that the paper that Sal was referencing was considering that spacetime was Euclidean, and that spacetime is obviously non-Euclidean in at the cosmological scale, and so assuming a Euclidean spacetime just means that this is just a very highly idealized situation that does not meaningfully map onto reality at all. So where their results just don't really even matter at that point.
I think what they were doing was and I might be wrong about this, but they were comparing a Euclidean space-time where tired light was a thing versus a curved space-time, the standard cosmology. So I think that's what they were doing.
Yes, that's correct. Although I would say that their standard cosmology with redshift and expansion and everything was assuming the same basic galaxies at all levels of redshift. Yeah. So they were assuming that the most redshifted galaxies were identical to the galaxies that we see today, which I don't think is a valid assumption, but that's implicit. And yes, they were comparing that with Euclidean space-time geometry with a tired light model that they were pushing and saying, look, our tired light model, which Sal tried to sell as a plasma model. Yeah, so he conflated that, but they were saying that was the best fit for the data.
It's interesting because even if you suppose this tired light and keep space-time Euclidean, it's still going to fail because it's still true that space-time is non-Euclidean. I can grant you tired light, space-time is still non-Euclidean. So I don't know why you would ever it just makes me laugh. But yeah, I think there was another paper. I think this was the one that had to do with the redshift with the solar and the satellite and the thing. Yeah. I can't remember all the details.
This is kind of Sal's big thing about plasma redshift. And
that model also assumed what was it called? A new tired light model or something. And I pointed that out, and I pointed out that there's just no meaningful peer-reviewed research it's a disreputable idea. Tired light, new tired light are disreputable ideas in cosmology. So, which they are. That is a fact.
What they're referring to is something by, I think his name is Lyndon Ashmore, which purports to have tired light without the blurring effects of images from other tired light ideas, but I haven't looked at it in detail. So I'm
That
like
does
you said,
sound
you
right,
definitely need to look at it from other people's perspectives to see, okay, is this really sound or is it garbage?
Yeah.
Well, the only thing that Rebekah brought up in response to the idea that like plasma would of course result in scattering and blurring of the image, she said, "Oh, but not small angle scattering." It's like, okay, so now you have to have a mechanism that explains why all the scattering would magically be small angle when it could conceivably be coming from any angle. I mean, there's no reason. It's just like,
what does that even mean?
Yeah, I'm not going to deny that it could be a legitimate term, but I am not familiar with it. But that doesn't really mean much. So
yeah.
Well, I just based on just the words, I would just assume that that's scattering that happens to have a small angle of like that would mimic kind of an absorption and emission, but still, I mean, the statistical odds that every single one of these interactions would be at a small angle, there's no reason to think that there would be a mechanism that would be making that happen, and there's no mechanism that's explaining it, then it just has to be a complete coincidence. The statistical odds of that happening would be astronomically
It's
small.
kind of a similar issue to what I was telling someone in a different side chat, I believe, the other day about, okay, could gravitational redshift be what's explaining cosmological redshift? And I point this out to them that, yeah, you can have redshift, but you can also have gravitational blue shift. And the fact that only nearby galaxies, for example, are blue shifted, whereas everything beyond our local neighborhood is all red shifted, that seems to be a very strong coincidence there. So similar to kind of what you were saying.
do either one of you want to tackle explaining what tired light is?
I guess we should each give our own take on it.
Well,
I mean,
the only thing I know about is it's this idea that light slows down over time. I don't really know much beyond that because, as far as I know, they don't actually have any explicated mechanisms for how this works that aren't complete bullshit. So
I'm not sure if it's slowed down, but I would say probably like loses energy as it travels a longer and longer distance.
Yeah. I think what most people describe it as, or the supporters of it claim, is that instead of expanding space, obviously, there's just material on the way, on the light's path, basically, and so the more material it interacts with, hence the more redshifted it becomes, and supposedly that's why we get the redshift distance relationship that we see.
Which is interesting. Oh shit! I would be curious to know if or how these individuals. Give me a second.
Ladies and gentlemen, I think we've reached 420 viewers yet once again.
Sounds about right. But I would be curious to know if they've actually given, or at least made, a serious attempt to show how it is that this light will lose energy in a way that is directly proportionate to the distance of the galaxy that it's coming from. Or if they just kind of vaguely allude to this idea that, well, the light could be losing energy because of interaction. Because I'm going to be honest, I don't think I've probably looked into tired light as much as you guys have. I haven't really looked a lot into like creationist arguments in cosmology because I've been too busy reading the actual cosmology.
Well, to be fair, they're very few and far between.
Well, the main thing is like either they say, oh, there's some kind of ether, or oh, it's some kind of friction interaction with just the background of space, or they come up with some whatever mechanism they want to justify tired light. But at the end of the day, every mechanism still entails blurring. So the fact that we don't see blurring both debunks plasma redshift and tired light.
Well, I'll actually give you another one, actually, because using the CMB, for example, and I employ everyone to look at astronomer Ned Wright's article on this, because he's actually uh, tackled a few of these arguments about tired light. And I think, if I'm remembering correctly, regarding the CMB, if you compare the CMB that we would expect from tired light in a static cosmology versus one that's expanding and diluting over time, diluting matter, I should say, and radiation, then the power spectrum, or the spectrum in general that you would get for the CMB, is very different compared to one between tired light and expanding cosmology. And in fact, if you actually look at the graph for the CMB, the error bars are so tight, like they're like very close to the actual line. So it's kind of a hit or miss thing. If you're either on the line and you got the spectrum, or you didn't, and you're just wrong. And tired light, unfortunately, didn't fall on the spectrum. So the CMB alone, too, along with the blurring, like you said, shows that no, tired light probably isn't a thing.
I also think it's interesting that in both mine and Grayson's opening, we outlined galactic redshift as a function of the distance of the galaxies. And at least 2 or 3 times I had to remind, I think maybe once for Rebekah and twice for Sal, something like that. Maybe it was just 2 times for Sal, where he kept going back to the redshift. And I had to keep saying redshift simplicator is not what we're looking at when we're looking at galactic redshift. It's not just that there's a redshift. It's that the amount by which the redshift occurs is directly proportional to the distance. The further away it is, the redder it is. That's the big thing. It's the connection between those two, not just that there's redshift there. And I thought that was interesting that I sort of, I don't want to say the word preempted, but sort of anticipated that in my opening, and we still brought it.
Well, you can tell he was still following his script despite what you said, because he brought up, of course, the meme about, oh, a police car, and Ewan obviously said it was expansion because they detected redshift between you and your car, or whatever he said. That was a funny bit for me, because he said that before a couple times. So. Right.
So yeah, there's actually something that I was surprised that Sal didn't bring up, and Leo, as far as you were talking about being familiar with some of the common creationist talking points around astronomy. Have you ever heard about the two-way speed of light?
Yes, I have. That's the only one I really know a lot about.
Well, Sal, I think, has brought this up before. I've certainly encountered this multiple times in dealing with creationists. Does anyone want to talk about the two-way speed of light, or should I just summarize what
you want to know how I handle this?
Yeah, that's exactly what I'm getting at.
There's a very specific way that I handle this. So the thing is, most astrophysicists, physicists, cosmologists, relevant experts are going to know about this quote-unquote two-way speed of light, quote-unquote one-way speed of light thing. But the thing is, it literally does not matter. There's no relevance in bringing this up at all. So what I'll do when it's brought up is I'll be like, I don't know what you mean by two-way speed of light. What it like, not like to play ignorant, but just to sort of paint this idea that you're just talking about an incoherent concept. Because I mean, it's a thing, but it's not really a thing. It's kind of difficult. Just to get them to be like, oh yeah, well there's the one-way speed of light, and then there's the two-way speed. I'm just like, wait, do you think that like we like point like a speeding gun at light and measure it as it goes? Like, is that what you think we're doing? No, we don't even need to physically measure the speed at which light is moving, whether from one destination to another or from one destination to the other and then back. It doesn't matter. We can just deduce its speed from the mathematics of electromagnetism and special relativity. And in fact, that's how we've verified the speed of light, is we've mathematically derived precisely what the value should be, and the observations that we've been capable of making line up with that. So bringing up some difference between one-way and two-way doesn't really mean anything. There's just the speed of light. And then they usually look at me, and then that's when they want to bring up, oh, but the anisotropic synchrony convention, and then that's a whole thing.
So what I like to ask them is basically, do you have any kind of plausible, like, mathematical or physics-based description of what kind of mechanism would cause light to go instantaneously in one direction and then in the return direction go half the speed
It
of
just
light?
does.
And that direction is just completely arbitrary too. It's not like there's actually a distinction in any of these directions, and there's just, it's completely incoherent. And then I also just wanted to ask, do you think that we could actually one day measure the one-way speed of light with, like, quantum entanglement? Like, if we
Maybe.
had, if we had communication systems that utilize quantum entanglement for instantaneous communication, and then we sent a light beam at the same time we affected particle A that was entangled. So the receiver instantaneously is aware of it because particle B, it's entangled pairs with the receiver. And then the clock starts to record how fast the light takes to travel from A to B. I feel like that would completely solve this whole two-way light
I think
speed thing.
the only problem with that, though, is that if you have clocks or any measuring devices separated, they must transmit information or coherent information between them. And entanglement doesn't really do that as far as we can tell. It's mostly still random because of the mathematics behind quantum mechanics. So you can't really transmit a message, for example, using entanglement. So we may be able to do it one day, but I don't see us doing that right now anyway.
Yeah, that is correct. Entanglement is not an actual transmission of information. It's a correlation between weighted sets of a similar quantum system.
Yeah.
So what about, like, quantum teleportation, like what they did with the photon across the Danube River?
Well, that's not really teleportation so much as it is just a particular instance of utilizing entanglement.
But that's what I'm saying. Couldn't they use the same kind of process that they use to, quantum teleport, whatever words you want to use, that photon? I mean, if they did that on a larger scale, where maybe it was like a light minute distance, then as soon as that photon comes out on the other side, the clock starts. 1 minute later, they receive the photon that was sent. I mean,
there would be no photon coming out on the other side. Quantum entanglement does not actually take a thing from some place in space and soup, now it's over here. It's a correlation between two different states of the same quantum system in their weighted sets. So you get weighted sets for what you could observe for those two states, and there will be a correlation between the values in those related sets. If you've got 3 here, you've got -3 here. If you've got 5 here, you've got -5 here. So I'm just using numbers as sort of there's that complementary correlation. If you've got spin up, then this one spin down.
So
it isn't like a movement of any information. It's just a correlation.
It was my understanding that if you were to, like, change or alter particle A in some way, such as absorbing a photon, then particle B would be affected in a complementary way.
Yes, the weighted set of possible measurements for particle B would change in a way that correlates to the change in the weighted set of measurements for particle A. But
so if
no information is being moved.
Well, if you could measure that change as a result of changing particle A, if you could measure that in particle B, then wouldn't that allow you to simultaneously, transmit information? I don't know. Maybe I need to understand this material better, but that was my understanding of it anyway. But we're going way off in the weeds now with the debate review, I guess.
I did want to answer your first question. Oh, yes, we can measure the one-way speed of light because there's only one speed, the speed of light in every direction, and we can do it without actually having to watch a photon move. We can just derive it from. So usually, I think it's the square root of 1 over epsilon naught mu naught, where epsilon naught and mu naught are two different constants in electromagnetism. Epsilon naught is the electric permittivity of the vacuum of space, and mu naught is the magnetic permeability of vacuum of space. So in simplistic terms, the epsilon naught tells us how the bare vacuum space will permit an electric field through it, and how the bare vacuum of space can be permeated by a magnetic field is what would be explained by the magnetic permeability. That's what they relate to. And so that equation, the square root of 1 over epsilon naught mu naught, is equal to c, I believe, or something like that. All I know is c, the speed of light, falls out of that. And the other thing is that the speed of light falls out of other areas of physics. It's not just in electromagnetism. It's in I'm pretty sure it's in almost every quantum field theory or effective field theory that we use, because gluons also move at the speed. It's a constant, as Andrew just said, in general relativity. So if we're going to argue that like it could be infinite, but then you could have it the other way, how come we don't need to do that? Or why aren't we doing that with all the other constants that we have?
Yeah, and I think that we both brought up in the debate itself that basically like the light speed you can calculate light speed based on more elementary physics and mathematics, and we brought up the reasons why you can't exceed the speed of light multiple times to them in the debate, and yet I'm sure that Sal will go on to continue to make the argument that, oh, well, the light speed is actually variable and it can change and it can be instantaneous and blah, 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 blah. I saw people in the comments literally being like, these guys don't know what they're talking about because you can change the speed of light. And it's like, do we need to say in vacuo like every single time that we reference the speed of light?
I got to be honest, that is really annoying, and I feel like most people that say that are only saying that to just troll. Like they're purposefully trying to just nitpick and find something they can just say you're wrong about, rather than trying to meaningfully move the discussion forward.
Honestly, I think that you're giving them too much credit when you say that. I think that they genuinely think that it's some kind of gotcha because they don't understand. Like they understand enough to make the mistake of thinking that light can travel at different speeds, like on the photon level, but they don't understand enough to I don't know, they're in a weird informational middle ground where they can think that they're pointing out a gotcha, but they really are not understanding the full picture.
To be fair, there are early universe cosmologies that do involve a variable speed of light, but that relates more to the problems some people have with inflation rather than the several billion years that light has traveled since then, which near as we can tell, it hasn't varied in its speed. So that doesn't really, it doesn't really help either way.
I just wanted to say quickly, there's we got some people in the side chat. The link is pinned if anybody wants to join. This isn't just us three. Other people can join if they'd like. And also that the thing about Jason Lyle's anisotropic synchrony convention is that it's actually pretty easily defeatable, because you can pretty easily utilize or derive a reductio ad absurdum against it. It's actually pretty funny.
Yeah,
I'd love to have a discussion with Jason Lyle, but he won't ever. Nope, that will never happen.
Yeah. Well, the main problem I see with Lyle's argument is that he's trying to have his cake and eat it too, so to speak, because on the one hand, he says it's a mathematical convention, in which case it doesn't really alter physical reality in any way. On the other hand, light is actually instantaneous in one direction and slower in a different direction, in which case that's, like you just said, easily refutable, because going back to redshift, for example, and this has actually been brought up to Lyle a couple times, I think, if light was instantaneous, infinite speed, actually coming toward Earth, then nothing would have time to be redshifted. I think Lyle's only response to this has been that somehow there's time dilation on a cosmic scale that does allow for things to be redshifted, but as far as I can tell, time dilation on those kinds of scales is pretty small and not nearly enough to cause redshift.
Doesn't he say it's like time dilation from gravity wells or something like that? Or I might be thinking of something different. But that is actually.
Speaking of time dilation, how did you guys think about the debate when, like Sal brought up that time dilation is not consistently observed, like with quasars or etc.?
He tends to bring up this paper by David Crawford, and I have a few problems with it, but I'll let you go over it first, Leo, if you want.
Well, so I know that the paper, as far as I am aware, at least, so I could be wrong in a second. I had to clear out the phlegm, all the phlegm that gets built up. But so I could be wrong on this, but from what I have seen, it's not actually. This isn't like peer reviewed. This is it appears in archive. I've seen it there. And there was another paper that's even, or I mean, it's earlier than this, but that has much more prominent names in astrophysics and cosmology attached to it. People like Sean Perlmutter. If I'm pronouncing that correctly, I think Alex Filipenko, that confirms like pretty definitively, yeah, we're observing these time dilation effects here, like that we can see this going on, and it's right the way that we say that we thought it was going to be. So what are you talking about?
Right. Yeah. Sal had a bone to pick with me about this a little bit ago when relatively recently, when I brought up this 2008 paper that pretty much destroyed his claim that there is no supernova time dilation whatsoever by Blondin et al. 2008. And his only response, his main response to it was, it's 2008. Crawford published in 2017, therefore it's not relevant to Crawford 2017. And despite the fact that I brought up to him that where Crawford does mention Blondin at all in his actual 2017 paper, it's very brief, and as far as I can tell, kind of misunderstands what Blondin and all were trying to do or what they did. So I don't know. I think my point still stands there.
Yeah. Before we get too far past it, I did want to say quickly about the anisotropic synchrony convention that Jason Lyle has so graciously gifted to us. Is that his whole point is that you can't measure the one-way speed of light because of special relativistic effects that will result from time dilation when you move 2 clocks away, such that you could then send a beam of light from one to the other to measure them. And those effects, regardless of how minuscule, are going to have a bearing on the measurement that you make. And for this reason, what you would have to do is separate the 2 clocks, send a light beam from one, and then back to the other in order to get an accurate measurement so that you can correct for the time dilation factor. But the thing is, and so what he says is that, so because of this, we actually don't know how fast light moves in one direction. It could be that it moves infinitely in one direction and then at half the speed on the way back. So it could be that the speed of light varies. The speed of light is not a constant. But the thing is that his argument fundamentally depends on special relativity, from which he derives the time dilation effect when you separate 2 clocks. And the thing is, one of the most fundamental postulates of special relativity, does anybody know what it is? The speed of light is constant. So he is assuming the truth of the constancy of the speed of light in order to argue that the speed of light isn't constant. And thus we have an explicit reductio ad absurdum. And through that, we can reject his argument and his convention altogether. It's logically incoherent.
That's great.
I think it should also be pointed out to him that just because it could be infinite in one direction and slower in a different direction in this conventional sense or convention sense doesn't mean it therefore is. Like, reality isn't dictated by mathematical possibilities necessarily.
Exactly. And that's the second objective, is that this is merely a convention.
Right. I did also, this might be going back to an earlier issue, but I had one other thing I want to say about the angular turnaround paper that was brought up.
Go ahead.
Trying to remember.
Yeah, Leo, have you looked at that paper yet? The one that they kept bringing that graphic from?
No, not yet. I don't think so anyway. I'm pretty sure I haven't.
This is
It's
actually
like
one. Yeah. Sorry, go ahead.
it's like what, like testing cosmological models with the JWST or something like that. It's like a very clickbaity title.
Yeah.
Who does anybody know who the author
Yeah,
is
it's
on?
by a bunch of like Russians from like
Mhm.
St. Petersburg affiliated institutions, but they publish it on Archive. It's not like it's published on any like peer reviewed.
What was the title of it again?
I think it was testing cosmological models with JWST or something like
Yeah.
that. What did you want to bring up about it? Rational empiricism.
Yeah. So actually two things I wanted to bring up about it. One was I skimmed through it a couple times, and it doesn't really seem to be anything novel,
This it?
really, to put it bluntly. Yep, that's the one.
Okay.
And
It's a little blurry.
really, when you go into it, and you can find a bunch of things very clearly that the authors admit that Sal and Rebekah did not bring up in the actual debate. To make it seem like the case was clear, for one thing, like you were saying earlier, Grayson, they admit, well, this could be an actual relationship, but on the other hand, galaxy sizes could evolve over time, so maybe. And the other thing was, like you were saying, it's based on JWST results, and in particular galaxies that only have photometric redshifts right now, which it's funny how Sal and Rebekah actually came across that, I think, when they were reading the paper the other day, but they conveniently did not bring that up in the debate because for anyone interested, photometric redshifts, while they are approximate, they're much less precise than spectroscopic redshifts, and I won't go into too much detail what the difference is there, but basically a lot of these galaxies that have been imaged by JWST don't have spectroscopic redshifts yet. So we're not entirely sure what their redshifts are, and therefore what their distances are, therefore what their ages are, therefore what their properties are. So a lot more confirmation is needed to confirm these properties. And until we can do that, this is really a premature analysis, in my view. It's not really something you can base this kind of grandiose argument off of.
Yeah,
And
and it says here
brought-
that. Go ahead.
Oh, sorry, Leo.
No, go ahead.
I was gonna say I brought up a lot of that in the debate when I mentioned the fact that these galaxies have not been like spectroscopically verified yet.
Yeah.
And Rebekah was like, "Oh no, they haven't. Look, they've all been spectroscopically
She said
verified."
the
And then
opposite.
she literally showed a graph, like the same graph that's in this paper, that is like not at all showing that.
Right. Yeah, I actually did really like that part. that made me chuckle.
Well, it's just I don't know if she was just not understanding like what like actual like spectroscopy looks like a printout where you see like the
Right.
different elemental compositions, but what she was showing as evidence that it has been spectroscopically analyzed was like just a correlation between redshift and angular diameter.
Right, which is based on the redshift confirmation in the first. Yeah, round and round we go. Anyway, were you gonna say something, Leo?
Yeah, exactly. Hey, P-Town.
Hey, P-Town.
Hey, P-Town. Good to see you.
Welcome.
We have a celebrity in our midst after he's debated Aaron Raw in front of thousands of people.
I wouldn't call myself a celebrity. I wouldn't call it a debate. We're just hanging out.
That's a good.
How are you guys? Good to see you guys. You guys Christians yet, or we still got some work to do?
Well, no, I'm not. Yeah, you do have a lot of work to do, like some logical contradictions to overcome. Good luck.
Well, let's talk about cosmology.
Okay.
Sure.
There's a lot of predictions in the Bible that foretell things that we have recently discovered when it comes to cosmology. That's a fact. What do you think, Leo?
All it would depend on what you're talking about. Perhaps I may agree. I would just need to know what you're talking about.
Yeah, did the James Webb Telescope discover the firmament?
That's a good joke.
It
Jason.
found
But how
God.
the
He
un-
looks like a giant duck.
it's like 16 times it talks about how the universe is expanding, how God stretched out the heavens. Is that what we observe?
So what I can say is that with respect to this stretching out of the heavens, I've spoken with people like Dr. Josh Bowen and Dr. Kip Davis on specifically this issue, and they are significantly more well-versed in the languages that these texts would have initially been written in, and also the culture into which they would have been written, as would Pat Lowinger, who's in the side chat. And what they have told me is that they would not have meant something like that space-time is expanding, because their understanding of what space was does not seem to, in any sense of the word, align with what physicists currently understand about it. So even if they were saying something that like space were expanding, that wouldn't mean anything like what we're seeing from physics. So I just have no reason to think that that's probably what they meant.
I will point out that stretching out the heavens is not necessarily equivalent to a metric expansion of space-time. Like you can have, I don't know, maybe the galaxies just happen to be moving apart for some supernatural reason, or just the wording there isn't really mathematically precise enough to make a statement like that.
Also,
Okay,
P-Town.
Go
P-Town,
ahead,
I was going to
Grayson.
ask a quick question. So all of the verses that I hear about this God stretched out the heavens is all in the past tense. It's like God stretching out a blanket. But I haven't seen any biblical verse, maybe you can enlighten me and share one, that would lead us to expect or predict that the universe was still currently expanding.
Yeah.
I think you're right, Grayson. Most of them are in the past tense. I think there are a couple that in the Hebrew language express that it was in the past and still is in the present. But I'm not a scholar like Josh Bowen or Pat Lowinger, but I could tell you, Leo, that God does say in his word that he stretched out the heavens like a garment, like a tent to dwell in. I think that it's simple and it is profound how he told the things that we will recently discover. And he said it thousands of years ago. It's really simple. Would you agree with me that the heavens are being stretched out?
Well, what do you take it by heavens? You're referring to like the cosmos.
Sure. Yes.
Okay. Being stretched out. No, I don't think I would say that. No.
It depends
You wouldn't.
what we mean by
No.
stretching out, because like are there literally gnomes at the edge of the cosmos pulling the fabric of space-time apart like that?
Well,
sort
let's
of
not
picture?
add gnomes, rational, empiricists. Let's be rational with this, okay? I gave you an example of. So how about stretching out like a curtain? That's one example in the Bible. So imagine now you're at one end of the curtain and I'm at the other. You're holding on to it on one end, I'm holding on to the other, and then you're walking away and you're stretching out this curtain. Isn't it consistent? Isn't that curtain consistent with what we observe in space?
No.
Well, the
And
problem
in
is
what way,
that's
Leo?
an
Well,
analogy.
because you would need to be doing some sort of like. I'm trying to figure out the best way. Because the first thing is that, like, in between my hands, I guess you could say that space is expanding, but the decimal place that is actually increasing that would be consistent with the expansion is so far to the right past decimal point that I don't think I'd be able to find it. I'd need probably several 100,000 years before I'd get to it. So it just doesn't matter. It's happening at larger scales, and see, expanding is almost not even the right word for it. That's the thing, is that we're limited as humans by our linguistic conventions. It's the scale in space measured over sufficient distances is increasing metrically.
Okay, so let me just clarify and let's stick with the facts here and let's take a rational approach. It is true what the Bible says, that the universe that we can observe is expanding, is stretching, and accelerating at, and is accelerating at, and it's stretching at an accelerating rate from our vantage point. That means the further away, those parts are stretching more. That's the same thing as being stretched out like a garment, stretched out like a tent to dwell in, stretched out like a curtain. This
I
is
don't.
consistent.
Except that it's not like because the curtain there isn't a metric expansion in its scale. That's not. So I'm not understanding.
There is, because the
Well,
part by which you pull on stretches
There
more than the
is.
part that's not being pulled. It's so simple, boys.
That's
It's
not
a
metric
fact. The
expansion.
Bible foretells the future in advance, and it talks about the past.
well,
I mean, so
let me put
yeah.
it this way. Let me use an analogy here. Let's say, okay, there is a curtain or a big fabric, basically just take a fabric of whatever kind, and let's put some marbles of various kinds on it. If you stretch it out, basically,
Mhm.
like a tent, like a curtain, you'll find that the marbles or whatever you put on it will all get farther apart from each other. Okay, but what they
Correct.
won't do is that right next to each other, for example, they're not going to stay right next to each other. Like, sure, you're going to get them farther apart, but there isn't any gravitational physics involved. There's nothing related to, like Leo was saying, the curvature of the fabric itself or what's going on the larger scales. You're just pulling at the ends, but you're not necessarily describing what's actually happening in there.
You are, if you continue your model, everything around those marbles would also be continually stretched apart from each other, just as the Bible says, and just as we observe in
Well,
science.
right, but my point is they're not all equally stretching apart from or expanding apart from each other. For example, within going into the actual universe, within a single galaxy cluster, space isn't expanding.
So
Gravity
if
is
that's the
boundary.
case, rational empiricist, if that's the case, I would like to know, because that would go against my interpretation of scripture, and I don't have an answer for you.
Well,
I'll be
I'll
honest
give
with
you
you.
a piece of evidence that is the case. All right, have you looked at the Andromeda galaxy?
I'm not well versed in
Or
this subject.
have you heard of it at least? Right.
Is it the closest one?
Yeah, it's the closest really
Okay.
big galaxy in our neighborhood. And if you actually look at its spectrum, it's blue shifted, right? That means it's moving toward us, not away from us. So it's being pulled, or we're being pulled toward each other by our mutual gravity, us in the Milky Way, or the Andromeda in the Milky Way.
Mhm.
So there's evidence that yes, galaxy clusters are bound by gravity. So not everything is expanding equally. That's why
I
it's
would
called a metric expansion, because it only happens on the largest scales, or that's one reason.
Sure. Okay. So there's possible evidence against scripture, which I'll look into that, and maybe I'm sure there's always an answer for it. But I
So,
appreciate you presenting that, because that stuff's important to me.
so
What about the
P-Town,
rest of the galaxies?
well, P-Town. So
Hmm.
my understanding, at least from of the historical perspective of like the era in time when the Bible was written, my
I'll be right
understanding is
back.
that their understanding of like the universe was basically that the Earth was a flat disk and there was a dome around it where all the stars were on this dome, and then beyond that dome was another body of water, and beyond that, that's where God and the heavenly spiritual realm was. So that's my understanding of the kind of universe that the Bible lays out for what we would expect. So that seems utterly debunked by what we actually see in the universe.
Well, they were clearly wrong, those people, but that's not what the Bible says. See, what science has done over time is dignified what the Bible actually says, Grace. And just because a bunch of people who didn't know any better said things doesn't mean anything to me.
Well,
The
those are
Bible
the
was
people
written
that
for
wrote the
us as well
Bible.
now. No, no.
Well, the people
I'm
that wrote
sorry,
the
Grayson.
Bible like had that
Let's
kind of
keep this
viewpoint.
let's keep this topic on science, Grayson, because now we're going to go down to a whole different,
Well,
that's Pat Lowinger territory, and I'm sure
wait.
he's roasting me in chat.
You brought up the topic of science reifying the Bible's cosmological perspective. So
And
I
you
was
want to talk
bringing
about
up,
something different. You want to talk about what some hypothetical people in the past interpreted the Bible to saying, or supposedly what they wrote, which I would say is not true. From a biblical perspective, from a Christian perspective, that's not how we approach Scripture. Scripture was written to stand the test of time, as it always has and always will.
Okay, well, in the Bible, it describes a separation of the waters as being among the earliest processes in the universe, which we don't have any empirical evidence that would show that it would be possible for waters to be existent back then. So,
We don't need to talk about the three or the waters in the heaven right now, Grayson. I don't think it's part of the topic, or about what ancient people interpreted the Bible as being. But the reason why I called in is because you and I, Grayson, have talked about this multiple times. I brought it up to you because you want a situation where how can we take, because I'm big into how the science in the Bible is evidence for it, right? How it has these predictions in it, and you wanted a prediction from me, and one of which was, if I think possibly if there was a way for us to measure the speed of light from the stars, if we were able to see that speed of light is slowing down, I think it would be evidence for the Bible and creation. And this is just a hypothesis of mine. And I was curious because you were talking about, what was it?
tired light.
Tired light. Yeah, I was hoping you guys could possibly let me know if it might be related to my theory. Because I don't know anything about
your
it.
theory is wrong.
Well, I
don't know.
Like we were saying earlier, I don't necessarily think tired light has anything to do with the light actually slowing down in terms of its speed. It's more tired as in losing energy, and that's what ultimately causes a redshift, according to this idea. But as far as light in general slowing down throughout the universe, we have pretty good evidence that that's not the case, at least within the past I think the latest was like 7 billion years, or maybe even further back, because we can look at the light coming from these ancient galaxies, basically, and we can measure what's it called? Like, am I blanking out on this? Help me out, Leo.
Wait,
So there's no science
Alpha.
behind this tired light thing. I haven't even
Wait,
Googled it.
what's the concept you're thinking of, Andrew?
What's the name for alpha? The constant. I know it starts with fine structure constant. There we go. Okay.
Oh.
Yeah. The fine
alpha,
structure
okay,
constant. Yeah. I was blanking out on that for a second. Yeah. Sorry about that. Yeah, we've measured the fine structure constant alpha out to great distances in terms of the light coming from these galaxies, and it would have to be a really big coincidence if this is indeed a constant, and yet the light is also changing its speed along the way, because, as you probably already know, Leo, the fine structure constant and light are very much intertwined. So yeah, that's one piece of evidence that we're pretty sure light hasn't really slowed down over cosmic time. I hope I made some sense there.
You did to me.
Oops, I might have shut down the chat.
Yeah, the fine structure constant, I believe, is what gives the strength of the electromagnetic interactions with charged particles. I believe charged. Okay.
Well, anyway, if it's not evidence for it, it's just a prediction I've always had. It's something I've mentioned to Grayson multiple times. So I was just curious. Like, I have no way of measuring that. I can't measure starlight.
Neither can I. But
No,
yeah. I think
Andrew, the photon is electrically neutral, right? Photon does not. Photon doesn't carry electric charge. I'm pretty sure.
No,
it's just the gluon. The gluon carries color charge, though. Okay, I'm trying to think. Are there any bosons that carry electric charge? I don't think there is. I think it's only fermions.
Sure no, there's the W plus and minus.
Yeah.
Oh, that's right. Wow, I'm so dumb. My God, I don't even know. I forgot those. Well, I need to brush up my particle physics.
I thought the photon was the boson of the electromagnetic force.
It is, but it doesn't carry electric charge.
Right.
It
Yeah, it doesn't interact with
I don't
itself. Okay.
think.
Now I
Yeah,
see
I
what
don't
you-
think the photon undergoes self interactions the same way that
Yeah.
like gluons undergo self interactions.
I-
Because
I
I think
misunderstood
that
what you were saying there for a second.
yeah, I think it's the self interactions in the gluon field that ultimately give rise to the asymptotic freedom of QCD of chromodynamics, where the force of the interaction increases as you pull, like say, two gluons apart, or rather, two quarks apart. The strength of the strong interactions holding them together increases, almost like a rubber band. Whereas for like gravity or electromagnetism, or weak interactions, I think even it's the opposite. And I think that has something to do somewhere in the math, in that really long line of math. I think that has something to do. What is this? Why are there two p-towns in here?
We're duplicating.
Just leave the one. Kick the other one back.
Oh, so wait, did I get that right? Hello?
Maybe he had some
Down.
technical difficulties.
Switch
one?
them.
Oh,
That was like an 80s action
Okay.
movie where you don't know which one to shoot. You're like, which is the real
I'm just trying to
P-Town?
level the playing field, boys, to bring it in back up.
can I kick the other one?
I just had it in backstage so I could do the chat.
Oh, okay.
Do you want me to do? So, do I need the other one backstage? Like, are you coming back on that one?
You can just leave it backstage, Leo.
Okay.
That's what I would prefer.
Okay.
Let me ask you though.
Okay.
It doesn't matter what I say. You guys are going to object to everything and not give any ground. I mean, it's just the way it is. It's the way the
Hey,
opposition
I've given
is
you
going to
ground
be.
before, P-Town. I have
One
given you
time,
ground before.
Grayson. Thank you. It means a lot to me. It really does.
I
I
can't
bring
tell
this-
if you're being sarcastic or not. But
No, I actually do. I tell people like you. I don't want to say it publicly unless you want me to, but I really appreciate that you said that one time.
Thanks, man.
It's hard going into the lion's den, as Leo would call it. Believe it or
We
not.
appreciate you being here, P-Town. Thanks for joining us tonight, at least for a little bit.
Mm-hmm.
What I wanted to talk about was something I continually bring up. It's not what you think I'm going to say. Maybe it is. We'll see. But it's a simple thing. It might be poetic. It might be whatever. But from what I can tell, the Bible predicts that the stars, Leo, are innumerable, can't be counted. Okay. You have to compare this to, though, relatively recent history. Let's go back 500 years when scientific people like yourself, Leo, okay, you enjoy this topic, you would write another Leo. No, I just counted all the stars and there's 1,523. And then another Leo would write back to Leo and say, no, there's 1,534. And you would argue back and forth because you have all this time in the world to count the stars. And this was a thing for a long time until the invention of the telescope, when we learned that the stars can't be counted. This is prophecy in the Bible.
Why can't they be counted?
My main argument, Grayson, is that they're more than 1,500.
Wait, hold on. I was muted that whole
emphasize
fucking
that.
time.
Let's
I'm
just
sorry.
emphasize that.
I was muted that whole time. Yeah. So there's actually something like 10 to the 22nd or 10 to the 24th stars in the universe, which is a finite number. And you can actually get that with some relatively simple calculations.
Well, God says in his word that he knows them all by name. So let's
Well,
remember, though, that
with
God
respect-
himself predicted this in the future. Why can't you guys just say,
with
yes, the
respect,
Bible
I'm gonna-
declared this first? Why?
With
Why
respect,
is it
I'm
so
going to
hard?
trust the European Space Agency over the Bible.
I don't want to be mean. You know, I'm full of Guinness and what is it called? Theraflu. But like, you guys just can't. Why can't you just say, yes, the Bible was right,
Because
that there was more than 1,500 and some change in the sky? Why is it so hard? It's because you have an agenda.
Wait, did the
Come
Bible
on,
say there was
Grayson.
more than 1,500 and some change stars?
The point is that it wasn't that the Bible emphasizes that they're not infinite, that the stars are not infinite, and that they can't be counted because that's how many they are. The point is that there was a lot of them, a huge number, where we can't count that high. The main point, though, is that it was more than 1,500 and some change that quote unquote Leo scientists would argue back and forth about how many there were when they counted them in the sky. The point is the Bible made a prediction and it was right. It's
But it
simple.
was wrong.
I don't
You can be
understand.
counted. It's a finite number. It's countable.
No, listen again. The Bible predicted that it's not infinite. So I would agree with you. There is a finite number, but you can't count them. You don't know exactly how many there were. Just unlike what the guys who would argue back and forth about how there being 1,527 or 1,533.
There is no reason why you can't count them. Like you're just saying they're more than 1,500, so that makes it not countable. That doesn't make sense.
I think if you want to say the Bible predicted that there were more stars than we knew about at the time, like a very large number, then sure, that's like a qualitative prediction that I guess came true, but that doesn't really
Nothing really turns
Thank
on
you.
mean
Thank
much to
you.
that.
Thank you. At least you got my point. Was that the point is that the Bible predicted science in advance. The rational empiricist wins.
I don't think that's really. I think most humans.
It
probably
really
have
wasn't that
lots of
hard, Leo.
stars
Like
back
why
then. And then we found
why
out that
is
there
it
are
that
a lot
hard
of-
to just why is it so hard for you guys to just give God credit a little bit? Like
Well, I don't
just
think
say,
God
yeah,
exists. So I don't know
can't
how.
you just say that the Bible got
it's
lucky? Just say God got lucky. I mean, whatever. But like tooth and nail say that everything's wrong all the time. Why? What's the
But
I
it
never
point?
said
didn't
that.
get lucky. That's I reject the even aspect that it got lucky because it wasn't right. It wasn't correct. They're not innumerable. That is not correct.
There's a difference between innumerable and infinite, Grayson. I just want to confirm that you're not getting it mixed up.
So what's the difference then?
Okay, so you are admitting that you were using them interchangeably, correct?
Well, what is I'm asking you what the difference is between innumerable and infinite. Because if it's not infinite, then it is numerable. There is a number that we can assign to it, and we have. There's 200 trillion billion stars, whatever. That's a number.
You know what's even funnier
There
is
is
that
a
you
difference
can get infinites that are numerable.
Grayson, to answer your question, the other product in this equation, I don't know the word for it, would be Grayson. See, Grayson can't count that high. That's what it means by innumerable versus infinite. Infinite is it just keeps going and going and going and going. Innumerable would be we can't count them. There's a difference. That's why the Bible literally is making your point for you as well, Grayson, that the stars can't be counted and yet they're not infinite. Why? Because God can name them all by name.
Yeah, but God could do that even
point.
if they were infinite.
Well, I think my main problem with this argument is that this is why I termed it a qualitative prediction rather than a quantitative one, because if you want to say, okay, we predict there's going to be a lot more stars than we can currently see, more than the human mind can comprehend. And yeah, sure, that's what's end up being true that most people would say. But the point is deciphering whether that's due to chance, coincidence, or something like that, or whether it has to be a much more specific prediction. It's basically akin to saying 100 years from now something will happen. That's not really points either way. So it's got to be a little more than that, in my take.
I just want to say one thing quickly to Sunflower in the side chat. There's a difference between able to count and countable. Whether or not you have the time to count something, like, so for instance, the set of natural numbers is countable. Also an infinite set. You could never complete counting it. That's still a countable set.
I think what your point is, it between, do you have time to count them all versus if you had time, could you count them all? That's what.
Well, but what I'm pointing out is that when you start getting into set theory, your basic notions about certain things and countability and infinites and stuff is almost certainly wrong.
Well,
Right.
I disagree with the notion that, like, okay, if there's too many for you to sit down and go 1, 2, 3, 4, 5, like that doesn't make it innumerable, because there are other ways
You're
of
missing the
attributing a
point,
numerical
Grayson.
value. Hold on. There are other ways of attributing a numerical value to the total amount other than just counting them one at a time. There are mathematical ways to ascribe a numerical value, and that's what we've done with stars. And if you just Google how many stars there are, you will get a numerical estimate. I mean, it's not innumerable.
I think it depends
is it
on
my
what we
turn,
mean by
or
innumerable.
should I let Leo jump in, or you guys want me to jump in? Look, Grayson, it's really not that hard. People like you, Grayson, and Leo, you both were arguing 500 years ago, 400 years ago, about how there's 1,500 and some change, or there's 1,500 and some change plus 2 stars in the sky. And then after the invention of the telescope, we found out there was a whole lot more, just as the Bible said there would be. It's really simple, boys. Just one of 1,000 things that the Bible predicts in advance. And you guys want to fight tooth and nail, not just say, okay, unlike rational empiricists, in a very different, polite, whatever way he did it, he said, yeah, okay, the Bible got lucky, whatever. I need something more specific to be convinced, is his argument. I don't want to speak for a rational empiricist, but
Yeah, that's
the point is,
pretty much what I said. Yeah.
okay,
Yeah, I
thank
agree
you.
with him.
Well,
If you want to
neither
call that
Leo
a
nor
prediction,
It's simple.
were-
if you want to call
yeah,
that a
neither
prediction,
Leo
that's
nor
fine.
myself were around 500 years ago. You're just putting words in our mouth about what we would have been saying 500 years ago. I mean, that's just a literal. Couldn't be anything closer to a straw man that you're constructing.
Also,
Look, I'm
I mean, if you
sorry that
wanna
it hurt
call
your. I'm sorry I hurt your feelings, Grayson. Just
You
because
didn't.
it was an analogy. I agree with you. Like, I didn't mean to cut you off, Leo. I agree with you. It was a straw man in the sense where but I'm trying to relay a message. I'm not trying to straw man you. I'm just trying to relay a simple concept here, honestly.
So the issue, if you want to call that a prediction, sure, but it's no different than saying, yeah, but the Bible predicted that there was going to be humans in the future, and look, there's humans in the future. Like, this is so broad and like so obvious, like it doesn't matter. Oh, look, people like 1,000, 1,500 years ago thought there's probably more stars in the sky than what we can see, and then we discovered that. Like, okay,
It's
sure, if you want
not,
to call
though,
that
Leo.
a prediction, that's fine, but it's that, I mean, that prediction underdetermines Christianity. There were numerous traditions that said the exact same thing. That prediction alone just doesn't, nothing turns on it. And I think that was also a point that Andrew was playing to. Is that, sure, you can grant that this is, I guess, to some extent a prediction, but nothing turns on this. It really just doesn't mean anything. It's like, again, saying that the Bible predicted that there was going to be humans in the future. Okay, and like, what
Plus,
turns
there are
on
lots of predictions in the Bible that did not turn out to be true, like
Yeah,
where it
that's
says
true.
that the stars will shine forever and ever, or that the earth will also be
They're not going to
eternal.
shine forever.
Or that the stars could fall to the earth, like Neil deGrasse Tyson said. To even make that statement shows how ignorant you are of what a star even is. And I don't even like
Okay,
Neil deGrasse
I'm
Tyson.
gonna-
That was a base
I'm
thing
gonna
for him to say.
I'm gonna pull another straw man, as Grayson would say it. Okay, so Leo and Grayson, okay, they're up in the mountains, right? And it's I don't know, 1653. Okay, and you're laying together on a blanket, looking up at the stars, and you're like, "Boy, we got nothing else to do here. Let's just count them." And you count them
Is this going to go
really
like in a Brokeback
diligently.
Mountain
At
direction?
15. I wasn't gonna go there.
I'm just like-
15,023. Oh, wait, we both counted the same number. you know what? We're scientists, so let's write whoever gives the crap across the other side of the world, and you're going to write letters back and forth and argue with each other. My point is that the Bible said there's a whole lot more than that. Simple concept. Yes, you can say
Yeah, great.
that God got lucky. You can make that decision.
What
I already know that there's only one
returns on this
thing that's
prediction?
gonna. There's only what? What'd you say? Sorry, Leo.
What turns on this prediction?
What turns on this?
Yeah.
What do you mean?
Why does it matter? What about this prediction in any way, shape, or form bolsters the truth of Christianity?
It just shows how you guys are ignorant of the truth.
Ignorant
That's
of
pretty
what?
much it. The fact that the Bible is divine.
Well, I don't know really what you mean by that. So yeah, I probably am
No, but
ignorant.
ultimately,
I don't know what that
you
means.
know, even your ignorance towards this simple one proof. When there's thousands of them, Leo, even your ignorance is something the
proof.
Bible predicted as
Couldn't
well.
couldn't we just say that you have been ignorant this whole time whenever we've shown where the Bible has made clearly false predictions about astronomy, and you've been ignorant of the fact that like these are clearly wrong predictions, like where it says that the moon is one of the two great lights and the moon is somehow emitting all this light in the sky?
Are you kidding me? Look, it is a light, as in it's not the source of the light, but it's a light in the sky, and they both happen to be the same
It's
size
not a
from our
light in the
vantage
sky.
point, Grayson.
Well, there's
The point is great. It's clear God made, yes, a light for day and a light for night. There's two great lights, and they're both about the same size from our vantage point. This is simple math, boys. It's simple probability. God made this stuff, gentlemen.
Well, the thing is,
That's not how math works.
Let me ask you, did God get lucky again? He got
well,
lucky again, didn't
the
he?
problem is I could grant that the Bible makes a bunch of predictions that have come true. I could just grant that. But the truth of Christianity is still going to be underdetermined. Like it's nothing is going to matter because there's still going to be a variety of issues that that Christianity isn't going to be able to overcome, that just drastically reduce, pretty much eliminate its likelihood of being true. So I can grant like all of these predictions, and at the end of the day, it's not going to matter. And those are the discussions I like to have about the real issues that face these worldviews. The foundation.
You don't want to have more talks about cosmology, then?
Well, I'm
you want to talk about
cosmology, but I'm just saying if we're going to talk about like cosmology as it relates to the Bible and how that means God exists, well, then I think that there's going to be some other exterior issues with the existence of God that I think are just going to factor in to are going to factor into what we conditionalize on when we're considering the probability of God's existence, or perhaps even the possibility of God's existence. But again, that's assuming the God of classical theism.
Leo, I agree with you. I think that the main thing when it comes to you opening up your eyes and seeing the truth that's in the Word is going to be a philosophical argument. Because right behind your head, you have all these planets, and you know with your knowledge that all of those different types of planets coming out of the sun over a long period of time happening by chance, the way that they are, is just statistically impossible. And this only you would know better than me, Leo, and you know that's true.
No, it's
they
more.
didn't come out of the sun. That's not how planets are made.
It's more that that I think that the Christian theism is logically inconsistent. That's going to be the main thing that's going to convince me. Somebody's going to have to try to find a way to resolve those logical inconsistencies while maintaining the truth of Christianity. And I don't think somebody's going to be able to do that. A universalist could get close to doing it, but they're still not going to be able to get all the way.
Well, for the next, I'm going to stop bashing on you guys. And
it wasn't bad.
So the next time we'll do a philosophical thing, Leo. I'll let you guys go. But thank you for having me. Grayson, always good to see you. Rational Empiricist, you've been wonderful. Leo.
These are I would say these are good questions and good topics to talk about. Just sometimes.
Hey, remember that Bible verse?
A little deeper.
remember that Bible verse where God set the earth on its foundations and so it would never be moved? Remember how the earth is never moving?
Yes, I
I
know
just had
that
to.
scripture.
Okay. Well, there's another failed prediction. So there's a lot of
I
failed
think
predictions.
that's after the flood, though, right?
It's
I think it
in
might be
Psalm
referencing something
104.
else. Yeah, I think going off my memory, I think it's referencing something other than what you think.
I
But
mean,
guys, I'm
how
gonna
does the
go.
earth have
Leo,
foundations?
my new channel. I want atheists to subscribe. So, can you put a link, please? It's at Dumpster Fires, and we can have philosophical
Do you,
discussions on it.
do you have a link in the? Okay, yes, you do.
He'll
All
put it
right.
in the private chat.
Copy. And
But
if
you
I could
gotta
click the
go,
right
P-Town. Thanks for joining us.
P-Town's
Anytime, guys.
channel is now in the side chat, and yes, you should go subscribe.
Appreciate you guys.
All
See
right,
ya.
peace out.
Thanks,
ya.
P-Town. Well, that was fun.
Wonder if
Yeah, that was
Sunflower
interesting.
comes here. Yeah, that was a good discussion.
I often come up against the
Yeah,
whole
out the
God
box
stretched
ones.
out the heavens thing.
Mm-hmm. Yeah.
Yeah.
So do I. But I'll trust the answers I get from people that like actually know those languages and those cultures, because I don't, and I'm sure the person saying what that thing probably doesn't either.
Well, yeah, they're not fluent in Aramaic.
No, they're not.
I don't know if this would help chat GPT's question about wormholes earlier. I'm sure Immutable Destiny probably already said the exact same thing, but as far as I'm aware, Einstein-Rosen bridges are very unstable. So I don't think you could use them to travel through space-time faster than light. You'd have to use a wildly more complex type of wormhole, if that's even possible.
The issue, as
So-
I understand it, is that as you would try to travel through an Einstein-Rosen bridge, it would continuously be expanding faster than you would be able to traverse it.
Yeah, I think it's also there. You have to basically keep it open, so to speak, with negative mass, which, as far as we can tell, isn't really a thing in the universe. So
Kind of a physically
if you-
incoherent thing.
yeah, a little bit, but yeah, unless that's kind of the issue. Chat GPT is you have to keep it from pinching off because it really doesn't want to be an open wormhole that way. So you have to have this kind of abstract type of mass to keep it open, and we don't know if that's possible.
Do you guys know? I mean, I know there was like a whole controversy about whether or not this was a real wormhole. I know Leo does not say it's a real wormhole, but the simulated wormhole in the quantum computer where they simulated an Einstein-Rosen bridge and they were able to keep it open and send a qubit of information through the bridge using like I was unclear of like I listened to the scientists describe like what kind of loophole in logic they were able to use to pass something through the bridge in their example, but I wasn't really able to follow it. I don't know if you guys are more familiar, maybe.
I mean, as
I'm
far
not,
as I
unfortunately.
understand, it was really just a novel form of entanglement, and the way that the entanglement was created was somewhat analog to what we would call an Einstein-Rosen bridge.
Yeah, ER equals EPR, right? I mean, it's working off of that theoretical foundation. But to my understanding, yeah, it was an entangled system. I think that they had 7 entangled pairs, but as you can get quantum computers that can get more and more entangled pairs, like 200 plus, you get more and more resolution in your simulation of a wormhole. But to my understanding, it was behaving in all the same ways that the mathematics would predict for an actual Einstein-Rosen bridge to behave. So it was like modeling the same kind of behavior that we'd expect to see in general relativity for an Einstein-Rosen bridge, but it was being modeled with entanglement. But there was some kind of trick that they did in order to like they were supplying some kind of equivalent of negative mass energy, like to keep the connection open in order to pass a qubit through. But they said in their simulated models, they were able to pass 1 qubit through one side and have it emerge out of the other side of their simulated wormhole. So I don't really know more details than that.
Yeah, most of the details I've forgotten because I haven't really talked about it since all that buzz that came from a bunch of websites that I think
Indeed. Yeah.
sought to, go more down the clickbait trail than the actual science communication trail. But yeah, it'll
I'm not
happen
sure
again,
if
I'm
this
sure.
is the answer that you're looking for, Chat GPT, to answer your question, or kind of not really answer your question there, but just to give you a nugget of an idea to think about. Do we really want to focus on interstellar travel when we have the technology and capability of fixing the planet we currently live on? I'm
going to be honest. I don't think that humans will ever engage in interstellar travel. Number one, I don't think that we're ever going to be capable of developing technology. I mean, and the thing is,
Debbie Downer.
I think that when people really understand the true scale between the stars. So at Proxima Centauri, the closest one to our solar system, is 25 trillion miles away. Humans, even the thing with interstellar travel is that even if we were capable of doing it, it's still going to be hundreds, if not thousands, of years of travel time. We're never going to reach probably even 30 or 40% the speed of light in terms of travel. It's just it's I think a combination of a few things. One, the kind of technology would be extremely difficult to develop if it could be developed by any species meaningfully. But number two, that
really
the interests of that species just aren't going to align with things like interstellar travel. We are going to be concerned with moving our resources toward other things like improving the existence of humans on this planet. I just don't think that interstellar travel is a thing that, at least for a very, very, very long time, humans are going to be concerned with.
Probably what
I'm much more of an optimist.
The solar system for at least a while, anyway.
Well, I'm much more of an optimist than you guys are. Clearly, go technology and science. We can problem solve. We can figure it out.
So apparently we have a musician here with us.
What is up? Blessed morning, my beautiful peoples.
How's it going? Now we just need Immutable to get in here.
Just chilling.
I guess he just wants to.
Immutable doesn't realize Immutable is hung up on something that's very silly. I wasn't trying to. I was kind of trolling, honestly. I wasn't trying to make an actual
really?
Point. Yeah. Like, I understand we can make accurate measurements without using our fingers and going 1, 2, 3. I was just kind of like being a troll and saying like you're not technically counting the stuff. It's stupid. It's not worth going into. Sorry, Immutable. Sorry.
Well, we'll see if Immutable joins us. I don't know. He might be busy.
Immutable comes in. How do you mute him?
With the mute button.
I guess unmutable and immutable are different words technically. I forgot.
Yes.
Oh, sorry.
Well, if humans ever unlock the technology that allows them to, like in the future, compress or expand space on their own, then all of the travel time issue is mute.
Lucy had to go do something.
Yeah, I had to
go. Alcubierre warp drive.
Yeah, warp drives. I doubt humans will probably ever develop one of those.
Sunflower.
Well, if it's possible, then we might. But
I think it's physically possible. I just don't think that it's pragmatically possible within the framework of humans and human society and human capabilities. And
I mean, 200 years ago, they would have all said that flight is impossible and it would be impossible for a human to get on the moon too. So
yeah, but this is the thing I bring up is the speed of light is a very different issue than the speed of sound. It's a different beast.
Traveling between the stars is different than traveling across the ocean from New York to London.
Yeah.
Well, yeah, but the point is that what is seen as impossible now is different than what was seen as impossible 200 years ago, which will be different than what's seen as impossible in 500 years.
I don't think it's impossible. I just don't think it's going to be anytime soon.
I don't even know if it'll happen at all. I just don't think humans really, at the end of the day, care about traveling between the stars. I think it's like a cool
Oh,
thing
you
to
guys
think
are
about.
Debbie Downers.
I don't think it's being a Debbie Downer. I think it's just actually the case. I think that it's one of those things that humans kind of like to think about when they get stoned, or like if they watch a really cool movie, and have some discussions about. But at the end of the day, I don't think any human would want to travel between the stars, because even if we could travel at the speed of light, which we can't, but let's just, for the sake of this, my point, let's just grant that we can travel at the speed of light. To get across the Milky Way galaxy, it'd still take you 200,000 years. Like, nobody's going to want to do this. Like, it's just, I just don't think that at least humans, probably any species that's sufficiently intelligent, would ever really care enough to make the attempt to develop the technology to do it. I just don't, I think that they would see it as largely a waste of resources. Why dump so much resources into trying to travel between the stars, and for what, when we could dump that into maintaining a meaningful and substantive existence for ourselves and our species on this planet? Like, just pragmatically, I don't think this is a thing that humans are ever going to do. It's not that it's impossible. I do not think it's impossible, at least not physically impossible. I just don't think it's pragmatic. I just don't think it's a pragmatic thing that humans are probably ever going to do. I think at best we might have some stuff in the solar system, a base, maybe even like a resort or something like on the moon,
Mars base,
in 1,000 years or something like that. Like, I do think that within the solar system or the Earth Moon system, there could be some interesting things, but interstellar, I really just don't think so. And I've been rambling, so I'm going to shut up.
Hey, Leo, can you highlight ChatGPT's second to last comment, please? It's coming in with some good questions tonight. As far as I'm aware, I think, or at least the current models are, I don't know if we've actually measured it per se. Maybe Juno has, but I'm pretty sure the current models are that they do have rocky or icy cores in the interior that's surrounded by a liquid metallic hydrogen layer outside of that, and then the rest is the gassy atmosphere. So that's what we currently think.
Mm-hmm.
Yep. Like a more
I
solid
will say
core.
the planetary science isn't my forte, so take what I'm saying with a grain of salt.
Same. I know the basics, and that's it.
Yeah, a more solid core in the center of the gas giants, and then also we would be able to point to the fact that a lot of these gas giants like Jupiter have very strong magnetic fields,
Right,
which would kind of imply a little bit more than you need the kind of core to have that.
Well, I mean, if the gas was sufficiently hot enough, you could be just fine. Look at stars. Stars have no rocky or terrestrial cores, and they have strong magnetic fields, but they also have nuclear fusion processes occurring in them, and a variety of other convection processes that can help aid in the production.
It's more dense. It's more dense in a star.
More dense. Yeah, that's what I'm saying. Is that if you could get the gas hot enough, you might be able to, but you might just end up with a star at that point. But you'd have to get enough gas.
Well, you would have a plasma. I don't know. I don't know if you'd have to be able to have a gaseous.
If I can quickly clarify something, and then I have a question for Chat GPT. So when I said ices earlier, I didn't mean liquid water ice. I meant just ices in terms of frozen ammonia,
water ice, ammonia ice, methane ice.
Yeah, methane ice.
So carbon dioxide. In its solid form, dry ice, I think is what it's called.
Yeah.
Isn't there an ice form of nitrogen?
Yeah, I think so.
Okay. Yeah, liquid nitrogen.
Yeah. So Chat GPT, if you're interested in gas giants, I'm just curious if you've heard of the term brown dwarfs before. That might be if you haven't, that might be an interesting avenue for you to look into, since you seem curious about this subject.
Isn't that where a white dwarf will eventually just run out of energy?
Let him
and
answer
become a brown
first.
Dwarf?
Stop.
Sorry. Well, what I was gonna say was, Leo, in our discussion with that Adam Lohr guy, I kind of wish that one of us had brought up the question of, oh, why don't we see a bunch of brown dwarf stars, or why is it that the night sky is dark at all? Like if the universe was just always existed, shouldn't we see stars everywhere? And
Olber's
or
paradox.
yeah,
Mhm.
I don't know. The steady staters are a weird group.
A weird bunch, yeah.
I guess Rebekah and Sal would technically be like looped into that because they don't think that there is a currently expanding universe or that
Seem to
space
take,
time
at
ever
least
expanded.
Sal seems to take a lot of his arguments from Lerner, actually. So I think he probably is a steady state guy.
Yeah, Eric Lerner, man, is both of them were, and
Sorry,
they were
not
talking
steady
about
state
him.
cosmology. I'm static cosmology. They're not the same
Yeah,
thing.
and they were talking about Eric Lerner like he's some kind of astrophysicist, which like
Yeah, yeah.
he's just a science writer. It's not like he's being published in peer-reviewed journals. It's not like he has any advanced degrees. I think he's got an undergrad in physics, and then he dropped out of grad school after a year to just be a science writer. He's not an astrophysicist. I mean, not that you have to be, but I mean, they talk about him as if he's an actual PhD scientist in the field of astrophysics.
Doesn't
It
he
says
have a
here,
physics degree?
Lerner received a BA in physics from Columbia University and started as a graduate student in physics at the University of Maryland, but left after a year due to his dissatisfaction with the mathematical rather than experimental approach there. He then pursued a career in popular science writing. So he has a
The
Bachelor
math
of
was
Arts in
too
Physics
hard.
from, yeah, well, either that or because it could have been like it was a very theoretically based program rather than an experimentally based program. He just didn't like that. He didn't like that it was all like theory and no experiment. Because there are like certain institutions where you go, where if you go in a PhD program, you may be working in more theoretical work than experimental. So he
Sounds like
just
coded
have,
language for the math is too hard.
I'm curious why he isn't getting a cosmology degree if he seems to know so much about all this. He should pursue his interests.
Yeah, probably just because he assumes that all galaxies, regardless of redshift, are fundamentally the same. Like they should have the same average size and composition and general behaviors, which is just an assumption on his part that we don't really have a good basis to make.
Well, I think there are such things as standard rulers in cosmology, but they're few and far between. And by the way, it's not the same thing as a standard candle for anyone listening. Yeah, I think like one of the main ones is something called baryon acoustic oscillations, which obviously is
one of my favorite things to talk about.
Yeah.
Well,
I was actually bringing this up it's pretty interesting. That's actually a way we can measure or indirectly measure dark energy's effects, by the way.
I think I brought up
the power spectrum.
I think I brought up baryon acoustic oscillations, the BAO signature present in the large-scale galactic structure in my discussion with Rebekah. I'm pretty sure I did.
And we brought it up in our recent debate too. I mean, we talked about like the.
Did we?
I did in my opening at least.
Okay. Actually, yeah, you did. Yeah.
I talked about basically the temperature fluctuations in the power scale of the cosmic microwave background.
Yeah, that's a good one.
And the acoustic, like the baryonic acoustic oscillations were what I used when I was talking about the neutrino background and how its predicted value was 1.95 Kelvin and the measured value was 1.96. Just another quantitatively verified prediction. No big deal.
Mm-hmm.
Have we directly measured that yet, or is it still indirect based on the CMB fluctuations?
Do you mean like, well, we've directly measured the CMB fluctuation values, like that 1.96 Kelvin that was directly measured in 2015. But in terms of directly measuring the neutrino background itself, that is still in the works because like neutrinos of especially that low energy. I mean, these would be like the most, neutrino equivalent to a redshift. I mean, they're very low energy neutrinos.
Yeah.
In order to measure them,
the telltale signature based on their influence on the CMB. I just didn't know if we'd actually physically seen it yet or detected the actual background yet.
So there's a main prototype, I think, in Princeton for a neutrino like detector device that would be able to measure these. But I think that they said that the technology was looking like it might be coming online in like 2023, but I think that there might be still a little bit off of that. So I think that they're still kind of, in the works of developing the kind of tech
Yeah.
needed to detect the neutrinos directly.
Going back to the baryon acoustic oscillations, didn't Rebekah in the debate bring up structures that were supposedly too large for to have formed, like
Yes.
cosmically speaking? I think it was like the large quasar group and whatnot.
Yes.
Yeah, I think the people or the actual astronomers I've talked to about that have told me you have to be careful between, okay, is this an actual structure, or is it kind of like a chance uh, alignment? Basically, is there or are you like, if you're looking for a big structure out there, you're probably going to find it. Whereas if you actually take the the whole assemblage of large scale structures that you see across the sky, I think using a good statistical method, then you probably won't see these as often. Like there might be an occasional slightly larger than average structure, sure, but I don't know.
I wanted to say, because I was reading the article from Ethan Siegel that I knew was out there on the cosmic neutrino background. It has been indirectly detected, but that the end of direct detection, I mean, the fact that it's indirect really doesn't mean anything. When we look at the Planck satellite data from the CMB and the fluctuations in the CMB, there's going to be peaks and troughs in them that correspond to like the matter content and radiation content, dark matter density, spatial curvature, dark energy, all that stuff. And if there were a neutrino background, there should be a very, very small phase shift in those peaks and those troughs in the Planck satellite data. And when we measured them, they should also be able to tell us what the temperature of that what the background that they correspond to is. And those phase shifts, I do believe, have been detected. The article says here, shit.
As far as I'm aware, it's also consistent with there being free flavors of neutrinos that we do see today, right?
Yep.
Okay.
Last year, a paper by Brent Fall, Lloyd, Knox, Marius, Milia, and Zepan came out detecting this phase shift for the first time. From the publicly available Planck data from 2013, they were able to not only definitively detect it, they were able to use that data to confirm that there are 3 types of neutrinos, the electron, muon, and tau species in the universe. No more, no less. So, I mean, I would consider that effective confirmation of cosmic neutrino background.
Yeah, I think it's pretty strong, but we're always wanting more,
Oh, of course, of course.
Yeah, it'll be even stronger once,
oh, yeah.
Maybe in a decade or more, whenever we get the actual technology to actually detect directly these neutrinos. But their existence, I agree, Leo, is basically evidenced sufficiently, for my view, in the CMB.
Yeah. Another pretty much well-supported prediction there for Big Bang.
Yep, exactly.
Rational empiricist, talking about these superstructures, I was going to ask,
Sure.
would inflation not be able to explain like their existence?
I don't know about that one, actually. I'd have to look at the specific mathematics behind it, but I can't say off the top of my head.
I would just think that if like during the inflationary epoch, that if these things were in direct contact or in equilibrium, then the formation of superstructures is not really that surprising to me. I don't know, maybe my logic, or maybe there's holes in my reasoning there, I don't know, but
I think that's a good point, but I think there's a gap between that and actually getting the structures together, like in terms of the matter physics behind it and the dark matter halos and all that. So it might very well contribute to that, but I don't think it's probably not the whole story.
I'm not sure how close the correlation between the sort of, I guess, the uniform nature of the temperature of the universe during inflation and the large scale structure would be. I know that the quantum fluctuations, the vacuum fluctuations in the inflaton field corresponds very, very closely with the large scale structure in the universe. But I don't know if the temperature and all that stuff and the uniformity of the temperature would just be auxiliary to that, or what sort of causal factors that would play.
Well, kind of on a side note, this seems to be a lately recurring argument by creationists or just counter Big Bang people. They somehow think the horizon problem or just a general extreme uniformity of the CMB is evidence against the Big Bang rather than for it.
Yeah, that makes no sense. I'd love it when I hear that one. And that's how you know that at this point, but they're just ignoring inflation. That's what they're doing.
Yeah.
Sucks.
Yeah, well, they
cosmology.
They always
model
try to
pattern.
make inflation seem like some kind of just like ad hoc solution that doesn't have any supporting evidence of its own. That's why, like, in
make
the
it seem
opening
as
for the debate,
ridiculous as possible.
yeah, that's why in the opening for the debate, I wanted to make sure that I supplied some like independent evidence of like verified predictions of the inflation model as well.
Like I'm personally totally fine with inflation if it turns out to be modified or replaced by a different idea that's maybe like similar to it, like a cyclical idea or a ekpyrotic model, for example. But I don't know, until we have the data that can tell one way or the other, like primordial gravitational waves, for example, I'll just have to remain open.
I'm not confident that inflationary theory will be overturned. Perhaps, maybe slightly modified, but I do not suspect that it will at all be overturned. Yeah. That's just me.
Yeah, I think like an idea, very like the basic idea behind it or something very similar to it is probably correct. I just don't know if any one particular model is gonna stand the test of time.
Mm-hmm.
Okay, so Leo, I've got to go soon, but before I go, there's one more thing from the debate that I wanted to bring up for some clarification. So during the debate, one of the question and answers came up about which came first, the chicken or the egg. And this was our biggest disagreement of the night, total drama, big drama. I said the egg comes first. You said neither. So I just wanted to ask for clarification. What makes you say neither? Because just to justify my answer really quick, eggs evolved with amniotes millions of years before chickens evolved. So it seems like the egg comes before the chicken, but I'll let you respond.
Well, so the reason I say neither is because I think that biology is just much more nuanced than simple which came first, the chicken or the egg. But also, while I don't disagree with your answer, I think it's an answer to a slightly different question, that which would be which came first, chickens or eggs, in which case I would agree eggs came first. But I think with the initial question, it's asking which came first, the chicken or the chicken egg. In which case, I would say it's specifically in that instance, I would say the chicken, because there are specific proteins, as far as I'm concerned, or as far as I know, there are specific proteins in the shell of the egg that can only be made by the body of the hen. So if we're speaking about specifically chickens and nothing else, then you would need a chicken before you could have an egg. If we're speaking broadly, which came first, chicken-like creatures or like eggs is first, but usually I just say neither, and that biology is much, much more nuanced and complex than that. But I don't disagree with your answer there, Grayson.
Yeah. You can come out from multiple different ways.
Tell me about how needlessly complicated biology is. Don't get me started. It's
that answer makes sense to me. That answer makes
Yeah.
sense to me because, I mean, when somebody says, you know, when was the first dog born or whatever, like when did a non-dog give birth to a dog? I mean, the best analogy that I hear people bring up is like with languages and language evolution and saying like, you know, who was the first French speaker? When did non-French speakers give birth to a French speaker? So Leo, your answer of neither does make sense if you're saying which came first, the chicken or the chicken egg. In that regard, it would be neither, because it would be like the line of demarcation of which you could say, okay, well, this is definitely a chicken and this is definitely a chicken egg. It'd be impossible to draw that on finer generational details. So it makes sense.
I mean, and the thing is too, like to switch the example a little bit, like according to like some paleontologists that I listened to, like the transition between like certain like dinosaurs and birds, even the birds are themselves dinosaurs, like is as hard of a question to answer, because there's like forms in the fossil record where like they're very much exhibiting like dinosaurian traits, but also like starting to exhibit also traits that modern birds have. And so this kind of gives the question of like, when does it become more bird-like than dinosaur-like? Like,
the transition is mosaic.
Yeah, and the thing is too, it's like this is one of the things. And there's
Grayson.
this,
I'm sorry. Go ahead, Immutable.
Oh no, I was just gonna say like that's one of the things that's kind of like central to biology and taxonomy as a system, from my understanding of it, is that to some degree or another, like what you choose to call a species or what you choose to call one thing over another is at some degree arbitrary, right? Like there are no principles like that tell you, like ab initio, how to classify something. Like we have to make a decision on okay, these set of characteristics.
We should do away with species concepts altogether.
There's one thing I want to say, not that I disagree with anything that you said, Immutable, but I do personally take issue with the word arbitrary, because arbitrary generally means without reason. But I would say that we classify things the way that we do for reasons. The word I would use is it's conventional.
Yeah, I mean, when I mean arbitrary, I don't mean like for any given, like for
you mean
particularly random reasons. Yeah, I mean, because in theory, like there's other conventions you could use to construct taxonomy in the way that we do, and you can still get consistent branchings, like in consistent phylogenetic trees. They would just look different because the criteria you use and the statistical, things you do are going to be different.
I mean,
and by the way, I will be actually kind of having a debate coming up later this month with Nephilim Free of all people on what topic? Wait, of transitional forms in the fossil record with mosaic properties. So I'm going to definitely be bringing up dinosaurs and birds and all kinds.
Do you know who Nephi is, Grayson? Have you met Nephi before?
I've been aware of Nephilim Free since like the early days of YouTube. Like it seems like he's been here for like 10 years now.
I remember him from the Pal Talk days.
That's where I first met Jack and Strike. Yeah, Leo, I've listened to your debate with him, and it is it's hard to listen to because of the amount. Oh my god!
I mixed in a little bit of trolling because I had to, dude. I can't not. But yeah, dude, I first met Nephilim Free on Pal Talk, Jack Gang Strike on Pal Talk. Dark Dawkins, he was known back then as Evolution False on Pal Talk. I'm pretty sure that's where Josh, the realistic nihilist, I think he was on Pal Talk as well. I think Venus was too.
Debate with him once, I think, and went on his channel a little bit.
Oh God, going on his channel was just... Yeah, going on his channel was just like, I don't even know how to describe that. That was trying to sail a 20-foot wooden boat through a Category 4 hurricane.
I think there was one point some people, or like Speed was calling me the Nephi Whisperer, but I don't think that lasted very long.
I'll be right back, guys.
Boy, is that a compliment now? Jesus hell, that's yeah. I mean, what I would say, and this is particularly true of Nephi, is like don't underestimate just how little creationists understand things.
Yeah.
And just like, because at certain points, like I remember, like my example is with John Maddox, and him bringing up this initial thing that initially like stumped me, like with ribosomal pausing. But it turns out he thought ribose is a protein, which is just hilarious, because like for those that aren't like familiar with basic biochemistry or like from freshman biology, ribose is a sugar. It's not something like that has the same type of chemical structure as proteins, but it's just like in a conversation where you're talking about biology and similarity and like what things are related to what, like if we're going to go down the route of like, oh, ribose is a protein, what? Like you're not even
also the same John Maddox who claimed that if we found a human was born with wings, we would claim that was evidence for evolution.
I think so, probably. I mean, it's just
he's claimed a lot of crazy shit. I've
Yeah.
debated him on the past. I've got a video on my channel of highlights with his debates of just nonstop owning him and trying to educate him on all kinds of topics.
But to the extent
is somebody falling down a cliff?
Jesus Christ.
That's not my mic. Yeah, that's not my mic. Okay. I thought that was mine for a second. I was like, that can't be right. But no, but the thing is though.
Oh, hey guys, I've got to go. So thanks for having me on, Leo.
Good to see you, Grayson.
Thanks for the
Take it easy, Grayson.
See you.
Yeah, take care. The reason I was we were talking about not Nephilim. Actually, we were talking about Nephilim and how like Nephilim is particularly uneducated when it comes to just anything and everything biology.
And
kind of how
just drop the biology part, just anything and everything.
Oh yeah, kind of like Maddox when he claimed ribose is a protein, which just absolutely wild claim. I mean, you could look at a basic like undergraduate like biochem textbook, which I know he has access to because it's in his document, like for the annoying people, as he's called it, and it's like one of the first chapters there.
What makes you think he's actually like read any of that meaningfully?
Yeah. Oh, I don't. I don't think
he did, what makes you think he walked away? Like, dude, I'll read articles in the SEP and have to read them like 3 times, and that's fucking goddamn philosophy, dude. That's not biochemistry. Now, there could be a debate as to which one is actually harder, but I'm not gonna start that right now.
I mean, it's just like I think the reason I bring that up is kind of like the kind of like spat me and Sunflower were having earlier. It's like, sure, to some effect, like conversations we have about the difference between counting and approximation are semantic, but you really have to be semantic at some degree, because otherwise you can't talk meaningfully about things. Well,
I like the way you worded it. That's why I highlighted that comment. That you've got to get into the semantics if you want to have a meaningful discussion about complex issues.
Yeah, it's like, because what a mathematician means when they say something is countable is very, very different than what normal people talk about when we say something is countable. Like, I brought up Avogadro's number because it's like, okay, what Avogadro's number is, it's the number of molecules like in a mole of a substance. But the number is huge, like it's 10 raised to the 23rd power. Nobody has counted that quantity physically. Right, it's something that's gleaned off of observational data.
That's too complex, immutable. If a 4th grader can't understand it, then why should we believe it?
Oh, there we go. I mean,
sorry, my terrible impression.
It's just, but the thing is though, like there are weird things in math where like the number technically is like where it's countable, but it's basically not computable.
Yep.
Like an example of that is a number called tree 3, which basically, like the short of it, is it's a solution to a question of combinatorics, and the number is famous because there's results that have been proved about the number, mostly in the fact that you can't compute the number. Like you can't compute the number like in this time span of the universe. Like the number of symbols it would require is like 10 raised to the 997th power.
Ooh.
And even at like, the quickest speed you can imagine typing that's permitted in the laws of physics, you get nowhere near close to computing all of the digits of the number.
Which number is this?
It's called tree 3.
Didn't know about that.
Oh yeah, I mean, like there's all sorts of weird numbers that exist that are, that are born basically out of these kind of weird questions in combinatorics or set theorists doing things. And it's to what Leo was saying earlier, I mean, you talk to a mathematician about countability or some of these things, you're going to find out that your intuitions about what something means to be countable or something like that is a very technical notion, and it's important to to say what that is. Because saying because the practical sense of it is, if you're saying we can't count how many molecules are in a drug being administered, well, you shouldn't really think chemistry is legitimate then. If we can't do something as basic as counting the number of molecules in a sample, that's a very bad precedent for trying to do experiments and things related to reactions or whatever. And it's just, I don't know, for me, being cautious with language.
I believe in mathematics or in set theory, a set is countable if its cardinality is isomorphic to that of the set of natural numbers or something like that, something along those lines.
I think what it means, in the
or
basics,
not isomorphic. I think that's the wrong word to use there.
Yeah, I'll give you my basic understanding of it, because unfortunately, set theory is one of those things where it's very, very complicated and hard to describe
simply.
precisely, in part because I haven't studied formal set theory. You learn a bit of it during undergrad math, and even that's kind of here's what the union is, here's what the intersection is, here's what certain things in set theory mean, but not full-blown set theory.
Mm-hmm.
The notion I'm familiar of with countability is referring to the question of if you ask, is the size of the amount of even numbers equal to the set of just integers themselves? Well, the answer is yes. And the reason for that is that there's a mapping between the set of integers to the set of even numbers. Right?
Bijective,
so,
right?
But yeah, bijective, I believe. So what
one-to-one correspondence, I think, is what bijective means. Just for people who don't know the word bijective.
It means that you can map every element of a particular set to something else.
Yeah,
it's
so you could say
X
goes to 1, Y goes to 2, Z, or A goes to 1,
3.
B goes to 2. It's a one-to-one mapping from one element in this set to one element. Every element in this set maps to exactly one element in the other set. One-to-one correspondence.
Yeah,
bijective.
Exactly. Yeah, exactly. It tells you that there's a way in which you can start with any number, and I can tell you what the number generated is based upon what you gave me. And that's one of the senses in which countability is referred to.
Wait, you mean to tell me that functions are just mappings between sets? I'm sorry.
Boy, that's don't get me. Yeah. But then you also I kind of want to talk about the continuum hypothesis now and how I don't like it, because it's one of the weirdest things in mathematics. It's one of the few times in mathematics you can say the answer is kind of based upon what you choose, what you decide on beforehand. In basic terms, what the continuum hypothesis is it's a question about sets, and particularly their cardinality, or kind of how big sets are, if you will. So we're talking, the set of naturals is something itself that is countable. It's infinite, but you can actually list the terms one by one if you wanted to. The set of real numbers, so things like pi, e, numbers like that, are a different kind of number and belong to and have a cardinality that's uncountable. They're both infinite, but they're different kinds of infinity. And what the continuum hypothesis asks is there a subset of real numbers such that the cardinality of the set is intermediate between that of the natural numbers and that of the reals? So it's kind of asking the question in very, very basic terms, but this is probably not technically correct at all. Can I construct for you a set that has a size that's somewhere between countable and uncountable?
Mm-hmm. Yep. And just again, for the audience sake, cardinality in simplistic terms refers to the number of elements in a set.
Yeah, it refers to pretty much. And the resolution to the continuum hypothesis, which I'm very much so opposed, like I don't like the resolution for various reasons, is that it depends on what version of set theory you want to use, because there's models of set theory which are consistent with the continuum hypothesis being true, and there are models in which models of set theory in which the continuum hypothesis fails to be true.
So I have a question. If the continuum hypothesis is true, then that is essentially saying that there is sort of a continuum between countable and uncountable sets. And then,
yes.
or is it
so one of the,
okay? And so then
one
if
of
it's
the
false,
weird,
then there is no continuum between countable and uncountable. Infinite.
So this is one of the interesting things about the continuum hypothesis itself, is that one consequence of the continuum hypothesis being true is that in principle, if it's correct, you can construct a function that, much in the same way you can do like counting with integers, where you could start with a set of reals and that function would effectively tell you like how to order the real numbers, even though they're uncountable. And it's absolutely, I mean, the world of set theory is bizarre. That's all I'm going to say.
So Lee, did you recover from your debate with Sal and
recover? I mean, I thought it was all right.
But then again, I mean, you also get into weird things where, like, depending on how you define convergent, you can get the sum of all integers to be either infinite or negative 1/12.
Negative one. That's.
Oh, did we get to set theory from the discussion about chickens and eggs? Like,
I have no idea.
We got to the conversation of set theory because of like the importance like of semantics. Like when we talk about, not just when we talk about science, but also when we're trying to communicate things in a way that's like mathematically precise.
Yeah.
And there is actually, funnily enough, a relation between semantics and set theory.
Oh, I don't doubt it. I mean,
semantics is, or at least can be, represented arithmetically.
Wouldn't doubt it. That's probably why category theory exists.
And model
I would. Oh, sorry.
No, go ahead.
I would say that about the chicken and egg problem. I would say that like if you specifically talk about the chicken egg, and if you define chicken egg as eggs that are laid by chickens, then they appear at the same time, because it's a tautology at this point, right? Like, oh, well, what happened first? Did you become married, or did you stop being a bachelor before? Like, which came first? Like, it doesn't make any sense to at that point. Yeah. All right. I'm sorry for that interrupting.
That's such
No, that's an interesting.
Nestle, I do have an interesting question for you. Like, and this kind of goes like to the like questions regarding origin of life that are more, I guess, semantically oriented than they are.
Say that 2 more times. Let's get Trace in here.
Like, do you think
I'm
it
actually
makes
interested
sense?
because I'm sorry to interrupt. Beautiful, go ahead.
Oh no, I'm more interested in like he debated who? Sal?
No. It's a guy on Pal Talk. His name is Alex. XX.
Oh yeah, I saw that.
I didn't watch the whole debate, but I did watch quite a bit of it. And it was, of course, Trace performed about as well as I thought he was going to. I mean that positively. He performed well.
Oh yeah, he's wicked and wickedly intelligent when it comes to this shit.
Yeah, well, he spent the last like year and a half, 2 years doing nothing but reading on it. He said he's just now finishing up most of his studies and his reading and everything in Origins of Life.
About Origins of Life. What was his name? Alex?
Yeah. It's Alex with 3 X's.
And just that, Alex triple X.
I don't remember what channel it's recorded on. Well, actually, I think it's an unlisted video, actually. I think it is. Because the channel...
Really?
Yeah, because the channel that it's listed on doesn't... If you go to that channel, you don't... I don't even think I'm going to be able to find the fucking channel.
Hey, Leo,
I see a channel, Alex Lee, but it probably is a different channel.
Yeah, I don't think that's it. What's up?
Well, what did you want to ask Immutable?
Oh yeah, sure. So I was meaning to ask the question: do you think like it's coherent to ask the question regarding like origin of life studies of did self-replication exist before like metabolism or things like that, like molecules which have the ability to like self-replicate, like was that before things like interacting like in metabolic cycles, or do you think like that kind of distinction is something like fundamental to the question, like to the origin of life, or that's meaningful in any way?
I think it depends on how you define self-replication. Of course, often when you talk about self-replication, you talk about genetics, right? Like the how DNA is replicated by the machinery, and even that self-replication is a bit of a misnomer because DNA doesn't self-replicate. There are many proteins involved that do the replication. So self-replication is more of a phenomena where you have like a set in place. Like there is no individual molecule that is able to, at least so far as we have discovered, there's no individual molecule that's able to replicate itself. It's more of a phenomena where you have a total set. Like is it of an individual?
Yeah. So you're saying it's a behavior of a set of molecules, more than
a set.
Okay.
Yeah, it's a component.
I
you
have a question.
a set of molecules. Yeah, and the thing. Oh, go ahead. Sorry, if you want to add.
Just a quick question. And I know this term can be applied, I think, a little bit more broadly, but wouldn't a better term be autocatalysis rather than self-replication?
That was going to
hearing
be
a
my
lot
next
more-
question.
That's exactly what I want
to
mention next.
autocatalysis rather than self-replication in the last few years in the field.
Yeah, that's actually the thing that I want to mention next. Like you have something called autocatalysis. Although again, autocatalysis, when you the simplistic version is is basically you have a molecule A, and molecule A is able to catalyze the reaction that will produce more of molecule A. But that is, I don't think that has ever been discovered so far. But there is actually
Wait, what?
Maybe there is.
Wait,
I think there is one example.
Autocatalysis?
Yeah, but there is a set autocatalysis. Basically, when you have a set of molecules that will produce the same molecule again and again and again, basically, in a molecular pathway, basically. And there are actually several of those pathways found in biochemistry. Like for one example is the citric acid cycle, or more specifically the reverse citric acid cycle. When the citric acid cycle goes into reverse, then you instead of burning, quote unquote, the molecules into carbon dioxide, you will suck up carbon dioxide in the cycle, which will double the same molecules again and again. It's a self-amplifying, basically, in the reverse.
Self-amplification.
Yeah.
Well, okay, but is that, like, to my understanding, like, is that process like exists? Well, is that process feasibly achieved because of like the enzymes like which allow like the catalytic barrier to be lowered for those reactions, or is it something like that occurs just as quickly without like biological catalysts, like, lowering the activation barrier?
Yeah, in life you have a very efficient catalyst that will, I think, like in many orders of magnitude, will speed up the reaction. But then when you talk about the origins of life, I think it is also something that I mentioned before when I was talking with you. Like when you look at proteins and their ability to catalyze reactions, the ability of catalysis is not inherent to the protein itself. It's more that they inherit the ability of catalysis from cofactors and coenzymes. Like,
well, sure. I mean, I think we would. I think we would agree though, like that that to some degree, like the geometry of molecules involved does govern, like the effective rate of catalysis, like an amplification of catalysis. And I guess the question there is like, okay, even if it's not like proteins necessarily, like, do you have like molecules with like with molecular motifs that are sufficient to like have the same level of catalysis occur?
Not on the same level, but it's
or to a sufficient degree,
yeah.
whatever you want to call it.
I've seen actually a recent papers by one name comes to mind, Nick Lane, and this team. They and also various other groups of research. They have shown that many reactions in the citric acid cycle, or there's also different names, like the carboxylic acid cycle is also often called, and they have managed to drive these reactions with the presence of various metals like iron and such.
Okay, yeah, that's promising in that case. Do you know if it's also feasible, like with reactions or like with processes that allow nitrogen to fixate to ammonia?
Well, yeah, that's something that I'm not very familiar with. But I think you know Dessel Drees, right?
Yeah.
And he had a conversation with Bill Marvin, I think, or Russell. Sorry, I forgot the name. Dessel Drees. What's his name again? The guy he talked to.
Yeah, I think I know what you're talking about. I just can't recall the name now.
Yeah, it's Michael Russell. It's also like Michael Russell is also one who promotes the alkaline vent world and with metabolism starting in geochemistry basically. And I actually asked him about nitrogen fixation and does he know how metals were perhaps involved in the fixation of nitrogen from
Yeah,
and they say probably yes. Probably metal centers were very involved in such reactions, even with nitrogen.
Yeah, I would imagine that would have to be the case almost, because my understanding, and correct me if I'm wrong, right? But the natural state of nitrogen tends to be that of like N2, right?
Right.
Like where you
it's
have
very stable molecule. Yeah. It's
exactly.
That's the explosive power of various explosive, like you know the recent, like many years ago in Beirut, you know, like the explosion. My God, like that's where the power comes from. Where you create a very stable molecule and then you release the energy from that, basically.
Yeah, exactly. And the thing is, like, that's from a biochemical perspective, right? Getting nitrogen like to separate and form like ammonia is very, very taxing metabolically, because you need to do a lot of things to get nitrogen away from like being in triple bonds and into a state where it wants to accept hydrogens rather than staying in this very nice configuration of a triple bond with another nitrogen atom.
But I think also go ahead, sorry.
Yeah, I mean, the reason I bring that up is, to my knowledge, right? Like, if you don't have nitrogen fixation occurring, I don't know how feasible it is to have other, like basic nitrogen molecules occur, like cyanoacetylene and stuff like that occurring,
right,
in a kind of prebiotic setting. Because it's like, okay, I could grant that these things are probably present to some degree, but how are you getting the nitrogen, like, to not be in N2 form rather than being in this, like, these other, like, chemically more versatile states where the chemistry of nitrogen is more versatile.
Right. I think like one reason is that it's like in the world without oxygen, then you have a very different situation where, like, with oxygen, the ammonia will often react to form to go back basically into the stable form, but
right.
But this is also about more details. I don't know. Like I would guess some speculation on my part, but I would guess like in the alkaline vents, you have lots of hydrogen, which is able to push electrons onto other molecules. Like I know more about how that happens with regarding to carbon dioxide. Like carbon dioxide, like when you put hydrogen and carbon dioxide, the favorable reaction is to produce biomass. Basically, that it becomes thermodynamically favorable to when you react hydrogen and carbon dioxide with each other in the absence of oxygen, of course. And perhaps something similar is going on when you have hydrogen and nitrogen without oxygen.
Perhaps. I mean, I remember, if I'm remembering like the classic nitrogen fixation cycle correctly, molybdenum
Right.
molybdenum is one of the atoms responsible for kind of like helping along in this process of fixating nitrogen into like ammonia. So I guess like if you're doing something with the hydrothermal vent setting, probably molybdenum is involved at some point in getting something like where something similar to nitrogen fixation occurs. But then again, I'm not an inorganic chemist, so I'm not entirely sure about like where exactly molybdenum is and like in its solubility in certain kinds of rocks. And stuff like that.
You would need a way to transfer electrons from an electron donor onto the nitrogen. At the same time, when the bonds are broken as well, so that takes a lot of energy. And so, as long as you have the energy and a way to add those to nitrogen, which is very difficult to do, yes. So, but I don't know if there is any demonstration about that with regard to like scenarios for the origins of life. Like,
yeah, I would have to
do more about that. Yeah.
The next time I see Drace, I'd have to ask them, because the kind of like pressing question is kind of like what's the favor, like what's the component that drives that entropically to occur?
Yeah,
because
it's also very interesting. Yeah, go ahead. Sorry.
Yeah, the reason I bring that up is like usually when you talk about a reaction being favorable, like or something like that, you're talking about it because like it's entropically favorable for the molecule to undergo that, because it increases the entropy of its environment. But the question is kind of like in a hydrothermal vent setting, why molybdenum over any other given metal? And also like what processes is occurring in hydrothermal vents that makes this process, more ready to occur than as opposed to not.
Alrighty,
so
fellas.
I'm
gonna wrap this stream up. It's get close to that 9:30 at least Central hour. So
can I have a final sentence or
yeah,
a
go
couple
ahead.
of sentences? It's a very interesting question. Yes, I agree. But I also find it interesting to note that in life, we have the metal centers are still very important in the reaction, and also it's not the proteins themselves. They do the stabilizing of the whole structure, but the most of the work is done by the metal centers, and that's very interesting to note.
Yeah,
but that's all I have to say for now. Yeah.
Right. Yeah, that is very interesting, because there's some very interesting like inorganic chemistry as well as like bioinorganic chemistry that occurs there.
All right. So thank you to Andrew and Grayson for stopping by, Nestle and Immutable, as well as P-Town, and I guess Sunflower. He was in here for all of like a minute and a half. And everybody that all of the like 9-10 people that have been consistently in the audience. This has been a fun one. I should probably do these more often. I never
It'd be
know.
Nice.
Well, I never know who's all gonna like be there, who's all gonna join. So it's like, I don't know, because I'm not one of the channels that's known for doing this, but I suppose I could, like, you never see the Gers and the Rages and anybody else who does this stuff in my fucking live chats when I'm live. So that's part of the reason why it's like, well, what's the point? Anyway, it has been fun. If you like the content on this channel, you should probably, I don't know, question your fucking life decisions or something. Definitely don't subscribe.
Every day of my life.
Anyway, yeah, you guys take it easy and, have fun out there, and get the fuck off the internet and maybe go take care of your families or something. I don't know.
There we go.